Welcome to AI Frontiers. Today's episode, titled cs.AI Unveiled, Trust, Reasoning, and Collaboration, offers a deep dive into the latest breakthroughs in computer science artificial intelligence. Drawing from 18 cutting-edge papers recently published on the arXiv preprint server as of September 18, 2025, this session explores emerging themes such as reasoning, trust, collaboration, automation, and security. Featuring an in-depth look at our paper of the day by Yue Xin and colleagues, the discussion uncovers why the next leap in AI is about more than just computational power. Artificial intelligence continues to achieve remarkable feats, acing math exams, composing academic papers, and engaging in debates with expert precision. However, a surprising gap remains. AI systems often struggle to reliably explain the reasoning behind their decisions. Picture digital experts collaborating in real time. They possess individual strengths, yet may miscommunicate, overlook critical nuances, or falter on intricate questions. Researchers are now racing to bridge these gaps, aiming to make AI not only brilliant, but also trustworthy and transparent. The stakes are substantial. Real-world safety, user confidence, and broad technology adoption depend on it. The central question persists. What will it take for society to genuinely trust AI in everyday life? Artificial intelligence is quietly embedded in nearly every sector: finance, healthcare, logistics, entertainment, and more. At the heart of this progress is computer science artificial intelligence, or cs.AI, a field devoted to developing systems capable of learning, reasoning, and communication. The focus is shifting from sheer computational power to the creation of trustworthy, adaptable intelligence. In this episode, current research trends and their real-world impact are explored, shedding light on how today's breakthroughs are shaping the technologies of tomorrow and why this evolution matters across industries. Imagine a bustling digital metropolis where artificial intelligence acts as the invisible network powering every building, from banks and hospitals to shipping hubs and entertainment venues. cs.AI serves as the engine room of this city, where intelligence is carefully designed, constructed, and fine-tuned. These systems are not merely rule followers. They adapt to new situations, solve unforeseen problems, and articulate their reasoning processes. Whether in autonomous vehicles, advanced chatbots, medical diagnostics, or real-time translation, cs.AI is omnipresent. Building such intelligence is akin to teaching a child not just how to ride a bike, but also to explain each maneuver, adapt to changing pathways, and avoid hazards, all simultaneously. One of the most significant themes in contemporary cs.AI is multimodal and collaborative reasoning. Modern models are engineered to blend visual, textual, and mathematical data, functioning much like a team of digital superheroes, each with their own specialized ability. For example, recent work by Yue Xin and colleagues tackled the complex challenge of geometric image captioning, enabling AI to generate accurate descriptions of intricate diagrams. Similarly, multi-agent frameworks are being developed to address medical and scientific problems, with specialized agents collaborating to enhance adaptability and real-world applicability. This approach, known as multimodal learning, leverages diverse data types to create richer, more capable AI systems. A crucial area of advancement is explainability and trust in AI systems. Research led by Smith and collaborators has focused on user-centered explainable AI for high-stakes applications such as infection control and ship navigation. These studies investigate how humans interpret and utilize AI-generated explanations, emphasizing that transparency is vital for building trust in critical domains. The explanation itself becomes a bridge between humans and machines, ensuring users understand not only what the AI decides, but also why. This is analogous to AI co-pilots who must clearly justify every shortcut or alternative route they take, thereby fostering confidence and safety. Ensuring the robustness, rationality, and security of AI systems is paramount. Alignment efforts such as those by Lee and colleagues target the improvement of self-consistency in large language models. Patel et al. Have introduced Sentinel agents, digital security guards that monitor multi-agent AI environments in real time. Rationality benchmarks are employed to systematically evaluate AI reasoning strengths and weaknesses. Furthermore, differential privacy techniques are being developed to protect sensitive data while still enabling the generation of useful outputs. Robustness serves as a safeguard, ensuring that AI does not make critical errors or display inconsistent behavior in high-stakes scenarios. Highlighting key findings from the research, several mini-stories illustrate both progress and ongoing challenges. Reinforcement learning with verifiable rewards, as demonstrated by Yue Shin and colleagues, significantly enhances geometric reasoning capabilities. The introduction of multi-agent debate mechanisms by Lee et al. Has improved model self-consistency by 27%. Autonomous research agents, such as those developed by Kim and team, are streamlining health informatics workflows. Patel et al.'s Sentinel agents have successfully detected all synthetic attacks in simulation environments. However, substantial challenges remain, particularly in the area of privacy-preserving text generation, as evidenced by the ongoing work of Gao and collaborators. The feature paper of the day, Generalizable Geometric Image Caption Synthesis by Yue Shin and team, addresses one of AI's most persistent challenges, accurately describing geometric diagrams. While AI models have excelled at generating captions for photographs, they often struggle with the complexity inherent in educational, engineering, and scientific diagrams. The real-world importance of this capability spans education, engineering design, and scholarly communication. The primary obstacle has been the lack of high-quality datasets containing precise geometric captions, with previous approaches relying heavily on inflexible templates. The motivation driving this research is to move beyond superficial pattern recognition, fostering deep, useful reasoning in AI. Delving into the breakthrough, Yue Shin and colleagues employed reinforcement learning with verifiable rewards, or RLVR, to revolutionize data pipeline construction. Over 50 core geometric relations were programmatically used to generate images, after which a reinforcement learning agent iteratively refined the captions. The agent received rewards for producing explanations that genuinely aided downstream models in solving real geometry problems. This process eschewed rigid templates in favor of adaptive, feedback-driven captioning. The approach was rigorously evaluated using challenging benchmarks such as MathVista, MathVerse, and the multimodal multidisciplinary model understanding dataset. RLVR thus represents a technical leap, training AI agents specifically for outputs that provide tangible problem-solving benefits. The results of this approach are significant. Models trained using RLVR augmented datasets achieved up to 5% higher scores on challenging mathematical benchmarks. Notably, these performance gains transferred to engineering tasks with improvements of up to 4%. The strongest benefits were observed on out-of-distribution tasks, indicating enhanced generalizability. A key lesson from this work is that the quality of data and the structure of feedback loops can be as impactful as model scale. This research sets a new benchmark for integrating visual and textual reasoning, establishing a foundation for more comprehensive AI systems. Looking forward, the trajectory of cs.AI resembles the transition from slow, uncertain horse trails to the innovation and reliability of high-speed railways. The field is evolving toward more transparent, adaptable, and trustworthy AI systems. Ongoing work focuses on rationality, consistency, and privacy, especially in sensitive domains such as healthcare and finance. Evaluation methodologies must continuously evolve to keep pace with the rapid advancements in AI. Opportunities abound for democratizing access to robust tools, enabling secure collaboration, and fostering the development of AI systems that are closely aligned with human values and needs. In summary, contemporary cs.AI research is addressing foundational challenges in reasoning, trust, automation, and security, as seen in the work of Yue Xin, Li, Patel, and their teams. Innovative methodologies are bridging the historical divide between raw computing power and much-needed transparency. The envisioned future features AI systems that not only collaborate and explain their processes, but also actively safeguard users and data. Listeners are encouraged to engage with the primary literature, contribute to ongoing discussions, and consider how these technological advances may influence their own professional and personal spheres. Remaining curious is essential. The next major AI breakthrough could emerge from the most unexpected quarters. This presentation has been synthesized by blending advanced AI tools and human expertise. Summarization and narrative structuring were facilitated by GPT 4.1 from OpenAI, while text-to-speech synthesis used OpenAI's TTS technology. Visual content was generated with Google tools, and all content underwent human expert review to ensure accuracy and clarity. Despite thorough review, minor oversights may still exist. References to all cited work are provided for transparency. This process aims to deliver a robust, accessible, and up-to-date overview of the rapidly evolving AI research landscape. Stay informed with AI Frontiers by subscribing for the latest in AI research and breakthroughs. The AI Frontiers channel offers deep dives into emerging papers, expert analysis, and ongoing discussions. Listeners are invited to explore additional episodes, review referenced studies, and actively participate by commenting, sharing insights, or posing questions. Thank you for joining us on the journey to the forefront of artificial intelligence. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.